already speak a lot, but I haven't recorded anything. Okay. Okay, that's fine. So he is senior lecturer on the Faculty of Chemical and Energy Engineering, University Teknologi Malaysia. The campus is located on the Johor. So UTM has two campus. One is on in Johor and the other one in Kuala Lumpur, right?
Yes.
So her academic background is from UTM. So you don't have a master's degree. You are directly from bachelor to PhD, right?
Yes, yes.
Okay, so similar to me. So that's why the student and the lecturer have similar, because we have the same educational background. So her research interest is on the material and manufacturing of polymer-based carbon membrane. This is the one that I took as my dissertation, as my PhD thesis. And polymeric inorganic membrane, or we usually call it as a mixed metric membrane. And also membrane technology for water and wastewater treatment and gas separation application, non-composite membrane for catalytic application, and visible light photocatalysis for degradation of organic polymers. So her research is mainly on membrane for various applications related to the water and gas. Okay, Norharyati Salleh. We usually call her with Dr. Yat. In lab, Dr. Yat. Amelia told me so, so I just follow her. Okay, so okay, Dr. Norharyati. Actually, we still have 7 minutes before we start, so maybe we can have some small introduction. If you have anything that you want to ask about the Dr. Norharyati, you can share. Okay, so before we start, the rule is Dr. Norharyati will have 40 minutes to present the topic, and later on we have 20 minutes to discussion. So we have approximately 1 hour installed. So please be active, guys, because we have a special guest. Orangnya ini bukan kaleng-kaleng ya.
Aduh.
Okay. Okay, sir.
So I should share the screen first. I will try. Multiple. So we choose multiple participant and no one. How to share the slide actually? Share screen.
Oh, really? That's one. Yes. Okay.
Oh, okay,
and
okay.
select your PowerPoint. You already open your. Yeah.
Okay, this one. Okay. You can see my slide. Okay.
Yes.
Because normally I'm conducting class using the WebEx.
Oh, I see. WebEx. WebEx. Yeah, WebEx Classico.
So I'm not sure.
Actually, WebEx. Okay, we still have 5 minutes. Or okay, guys. So before we start, I will just collecting the data from the student who are attending this meeting. So I will have saya akan absenkan kalian ya di besok. Okay, so we have. Okay, so we have the. Hello.
Hello.
Okay. Hello. Oh, I'm sorry. I'm still using the wrong virtual background. This is the computer. Okay.
Oh, how you change the background?
Oh, really? Actually, you have the on the
Uh-huh.
left corner bottom, you have microphone that mic and stop video, right? The stop video, you have an upside arrow, a small arrow beside the video icon. You can click it and choose virtual background. You find it? Have you find it?
No. We have mute, we have microphone, and then we have video.
Yeah,
Right.
on the left corner bottom di pojok kiri bawah di Zoom. Yeah, on the Zoom interface we have share screen, chat tools, participant security, stop video, and mute. Right?
Uh-huh.
Yeah. You click the upside arrow, the small arrow
The small arrow.
be, beside the video, and you click. There will be an option to choose virtual background, choose video filter, and video setting.
Oh, I see. Yes.
Yep.
And we can choose the virtual background.
Yeah.
None.
You can.
None.
Yeah, you
Why?
should set it manually. Actually,
Oh,
Zoom has a pre-installed virtual background like the bridge, this one, and this one, and this one. This
oh,
is
I
the
see.
pre-installed Zoom virtual background.
Okay, and we can also add image. So if you are dream, you are in Switzerland, you can choose the.
Yes, but
Okay.
yeah. But sometimes students are cheating because they took a screenshot of their image like this, their focus image, and then they set it as a virtual background, and then they turn off the camera like this one that I will. Nah, this one, if the image is their photo, really attending or taking attention to our topic. So that
I
is the student
see.
trick.
Okay. Oh, okay.
Yeah.
Okay,
Okay.
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 So
Cool.
start with this semester, we will do 100% online teaching. How about ITS? Same?
Yeah. True. We
Same.
also 100% online teaching.
Hmm.
Even for the experiment subject because it's a difficult one because experiment as a chemist they need the lab skill, right? But because
Mm-hmm.
the campus restrict the access to the lab for the first, second, and third year, so it's a bit tricky. Currently, for my subject thermodynamics, I use simulation. Actually, this
Mm-hmm.
is a free simulation that you can access from thet.colorado.edu. There is a lot of simulation there that you can use as a tool to explain something.
I see. Okay.
Okay,
Mm-hmm.
so maybe we can start, right?
We
It's
can start now,
already
okay?
9 o'clock.
Mm-mm.
Okay.
Okay, thank you. Hi everyone, Assalamualaikum. So, thank you Dr. Trianda and ITS for inviting me for this sharing session. So I call it as sharing session because I only share on one topics, the strength of materials. So hopefully this topic can relate with your subject as mentioned by Dr. Trianda is building material chemistry, right?
Yes.
So the strength of material actually, since my background is engineering, so we involve the calculation. So how about in the building material chemistry? They also have a calculation or something?
Actually, we
No.
just not really calculation. Where we just introduce what for affect a compound. This compound will affect in this one through
Oh,
the
I see.
chemical reaction like that.
Okay.
So more into a fundamental aspect.
So
But
probably
we would like
mm-mm.
but we would like love to see the how the engineer uh from the engineer perspective of the material, like strength of material, because we don't have students in the engineering field because into engineering as compared to the fundamental science, right? So we approach into fundamental.
Okay. So rasanya konten dalam slide saya ni kebanyakannya adalah background dia dalam kejuruteraan. So dia melibatkan pengiraan, the value. So daripada value tu kita tahu bahan itu boleh kuat ataupun berapa lama dia boleh bertahan. So
Okay.
basically yang tu strength of materials. Okay. So in general, kenapa kita perlukan strength of materials? Because kita perlu tahu after we choose the materials, we need to know what is the safety critical component that we need to consider. And also in the structure mechanic ataupun structure materials, we can relate their external force. Maksudnya tekanan luaran, internal force, tekanan di dalam bahan, deformation of the structure material adalah perubahan dari segi panjang ataupun lebar. So within the time, when the time pass by, dia punya length, dia punya diameter might be changed due to the shrinkage ataupun outside factor. So basically content yang akan saya share is the basic concept of the materials, respond to the loading. Sebab setiap loading, they have many types of loading. Loading ni adalah tekanan yang berlaku ke atas bahan tersebut. And also the fracture mechanic. Fracture mechanics is macam crack ataupun apa yang menyebabkan bahan itu boleh patah dan tidak bertahan lama. So yang ni actually gambar ni, the figure shows the reactor pressure vessel. So this is one of the component in the nuclear reactor. So I'm also teaching the nuclear engineering student. So some of the component and machine shows here is related to the nuclear as well.
Okay, cool. But Dr. Norharyati, excuse me, would you like to please the slide show your presentation?
Slide show.
Yeah, I think the shortcut is F5, Control F5. Right? That's one.
Control.
Slide
Okay,
show.
okay. The button is at the bottom one.
Yep,
Here.
yep.
Okay, okay.
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 Nice. Okay, thank you.
And we proceed. Okay, I divide into two parts. So the first one is the concept of the force, and the second one is what is the mechanism or types of the fracture that happen to the material. So the first one, so actually in the strength of materials, kita perlu tahu tekanan yang berlaku kepada bahan tu, they need force. So force ni adalah tekanan. And tekanan ni ada 3 jenis, which is compressive. As we can see from the bottom image, compressive adalah tekanan yang berlaku ke dalam, into the plane of the materials. And tensile adalah out of the plane. So maknanya you punya bahan akan tertarik lah, akan memanjang. And shear adalah parallel to the plane. Maksudnya dia ada geseran. So actually dalam satu bahan ni dia ada 3 jenis tekanan yang berlaku ke atas bahan. So we need to consider all 3 types of the force in order to design the materials. Contohnya you can imagine you want to design the bridge, for example. So you kena tahu tekanan yang berlaku ke atas bahan, keluar bahan dan parallel to the material. And also the moment. Moment adalah daya yang membolehkan bahan itu berpusing, rotation, ataupun we call it as torque. So bila ada satu pusingan terhadap bahan tu, we can measure what is the rotation force that can be exerted to the material. So dalam kita nak design satu-satu bahan, contohnya you nak design jambatan ataupun bangunan yang tinggi, they have several type of the support reaction. Support reaction ni maksudnya bahan yang memegang kepada rigid, solid building. Contohnya we have cable, we have roller, we have smooth support, we have external pin, internal pin, and the fixed support. So connection between the material, we need to connect several material so that we can build a big picture of the structure. So this is the types of the reaction on how we connect other material with other materials. Dia tak ada macam satu bahan tu, satu rumah you need to build with different type of material and how you connect each type of material. So this is the basic connection that you have to know. So yang ni contoh pengiraan yang berlaku ke atas satu bahan. So biasanya P ni refer to the tekanan yang berlaku kepada bahan. So dalam satu bahan, maksudnya at least satu batang kayu contohnya, they have several type of tekanan. So dekat hujung ni lain, dekat hujung lain, dekat tengah lain. Sebab kita ada connection with other materials. So setiap tekanan tu kita kena consider bila kita nak tahu berapa banyak tekanan yang dia boleh support. If not, your building will be break ataupun fail. So during the design of the any structure, we also need to know dia punya stress. So how to calculate the stress? Normally the ratio between the pressure is the force, A is the cross section area of the materials. So kita tahu setiap bahan dia ada different shape. Ada rectangle, square, circular, and even for the cylindrical they have a hollow cylindrical. So each type of material, each type of shape, they have different cross sectional area. So they have different stress. The stability of each shape of the material will be different. And strain is refer to the effect after you kenakan tekanan terhadap bahan. So bila you tekan, bahan memendek. Bila you tarik, bahan tu akan memanjang. So perubahan tu kita panggil elongation ataupun deformation. So the ratio between dia punya perubahan of the contohnya length ataupun diameter to the original state, we call it as strain. So the figure shows how the force can change or deform that particular structure. So tension is when the force is out from the plane. This is compression state. Compression state means that the pressure is come from into the plane, and shear parallel. So maybe dia punya structure akan bengkok after certain value of force. Okay, how to relate the strain and strength? So the sigma symbol is for the stress and E is for the strain. So the relationship between these two variables is we can relate with the Hooke's law. So the ratio of sigma to the E. So E, normally E is, we call it as modulus elastic ataupun Young modulus. Yang ni biasanya dia represent kepada strength of materials. So contohnya, you pilih material apa untuk build this kind of building? I choose wood. So normally the engineer akan tanya you ataupun contractor ataupun siapa yang involved dalam building, dia akan tanya what is the Young modulus for that kind of material. So from the E value, we know that how strong the material is. So different material, they have different value of E. How we want to determine the Young modulus ataupun E of that material, we need to conduct the experiment and plot the graph stress versus the strain. Then we can get the E value. Okay, dalam perubahan elongation ataupun deformation, so EL represent perubahan ke atas panjang and ED adalah perubahan ke atas diameter ataupun lebar bahan. So the ratio we call it as a Poisson ratio. Okay, material, they have two type of material, which is elastic and plastic behavior. So we can see from the graph here. So if you have this trend, this one is for the ductile materials. And for next one, if like this, your graph stress versus strain is like this is represent the brittle materials. So the difference is their value of the stress. Here we can see their yield strength is here. Yield strength means that when the point yield point is past some fraction of the deformation. So at the sigma y F yield strength, dia akan berlaku perubahan. So after perubahan tu, after that value, they will not be come to the original one. So means that they are permanent and non-reversible changes. So if your breaking strength is larger than yield strength, normally this one we classify as ductile material. For example, for the low carbon steel and aluminium alloy. And this is the process. Before the rupture, we can see here the length is changes and the diameter of the material is changes. But for the brittle material, for example, cast iron, glass or stone, you have an ultimate strength and breaking strength is similar. So they have no phase of the necking. So we cannot see any changes in the materials. They just rupture and fracture just like that. Rupture occurred without any noticeable prior change in the rate of the elongations. This is the two behavior of the material, ductile and the brittle materials. So during the selection of material for the building project, you need to consider this kind of the behavior. Okay, this is the example on how we calculate the deformation in term of the length. So kat sini sebagai contoh kita ada AB structure and BC structure that connected each other and this is the fixed support. So when we have two types of the force, yang ni tension stress and this is compression stress. So we know that AB, bila P dikenakan, AB akan memanjang. And BC, bila Q dikenakan, dia akan compress. So the length will be shortened. So we can, based on the calculation, we can calculate how far they can shorten, how far they can be long, the final length of the structure after we exerted the force. And this one only for two materials. So of course, when you are dealing with the bridge, they have a lot of connection. So each connection, you need to know their limitation. Okay, other than load or force keluar daripada bahan ke dalam bahan dan geseran, dia ada juga faktor lain yang mempengaruhi kekuatan sesatu bahan. So contohnya thermal stress. Thermal stress involve when you have temperature change. When a material is heat up to a temperature 2, final temperature from a initial temperature, the material expand and how far they expand is depends on the value of alpha. Alpha is the thermal expansion coefficient of the materials. So setiap material, steel, wood or glass, they have different value of alpha and the elongation lambda is refer to the elongation ataupun perubahan panjang bergantung kepada perubahan suhu dan juga nilai thermal expansion coefficient. So when you design, you need to know berapa tekanan yang berlaku and what is the surrounding temperature. So that's why in material selection, in London, they have this different type of material. In Malaysia, different. And the factor of temperature and weather is play an important role when you choose what type of material for the building. As I mentioned just now, we have several types of the structure. So this one is the example on how we calculate the force and stress for the circular and hollow circular shape. So the cross-section area, we have pi over 4 outer diameter minus inner diameter. So this is the main parameter that different. When you have different area, of course, you have a different stress. So if you have a rectangle shape, they only length times length times width of the material. And E, this is E. E value is the Young modulus, the mechanical strength of the materials, and alpha is their thermal expansion coefficient. So you need to include all the parameters in order to know their ultimate stress or what is the maximum stress that the material can boleh bertahan. So that is not rupture. And basically, to do this kind of calculation, for the engineering student, they need to know the static subject. So we engineer student need to take the static. It's like physics when you are in high school, and you need to have the basic of static. Then you can further your knowledge in the strength of material. If you don't have a basic static, there will be a problem to a student. Okay, just now we talk about the connection of the materials. So this is the type of the beam. Beam is the materials connected. They also have in one material they have different, not only one type of the connection, they have several type of connection. What's mean by the statically indeterminate means that you have more variables than the parameters. So you need to when you involve with the statically indeterminate beam, you need two equations in order to get the value of the strength of material. This is more complicated than the statically determined beam. Okay, when we have more than one force in one materials, for example, for this structure A and B, we have force 1 and force 2. So in between this force, they have internal force. So this force we need to calculate in order to know their strength. So in between reaction A and F1, we need to know their internal force. Between F1 and C, we need to know their internal force, so that we know their whole strength of the material. Okay, basically in design procedure, they have 4 steps we need to consider. The first one, we need to determine their mode of failure. This one and the choice of the materials. And when you know the mode of failure, you need to know their quantity. For instance, their maximum normal stress, their maximum strain for that particular material. And then after we know the material and their maximum normal stress, we need to test. Simple test on tension and compression. So we know how far they can sustain the tension and compression. After that, we need to calculate their safety factor. On how we determine that is using this simple calculation. Ultimate stress, the ratio of ultimate stress and allowable stress. And if you don't have a value of stress, you can calculate based on load. Load adalah tekanan, ultimate load and allowable load. So berapa banyak yang allowed and berapa banyak maximum that the material can sustain. So this ratio, this value is represent the factor of safety. And other factor that we need to consider when we want to build some structure is their material properties, their loading and loading cycles, type of failure, maintenance, how many times they require maintenance, and also the influence of the machine function. Of course, when we want to build something, we want to have a building that can sustain longer times. So the material selection is very important. And when you choose the material, you need to prove with the calculation of the strength of material. If they cannot support high load and only can be used for the shorter time, of course you need to change other materials. Okay, this is for part 1. Any question so far? Okay, I proceed with the part 2. Part 2 is the type of the fracture mechanic. Fracture adalah crack. Crack adalah pecahan. So, the definition of the fracture is the separation or fragmentation of the member into two parts. So, maksudnya you have satu bahan, sebatang kayu, dan bila dia fracture berlaku, they will be separate into two part ataupun three part. So, you punya bahan dah rosak lah. A methodology to assess cracking behavior which lead to a fracture, assuming the existence of crack in the solid body. So of course material within after time pass by they have a crack. Biasanya crack ni adalah indikator awal yang menyatakan bahan tu dah tak boleh guna ataupun boleh guna dalam masa 1 tahun atau 2 tahun sahaja. So this is the type of the fracture, brittle fracture, ductile fracture, fatigue fracture and creep fracture. Okay, dalam satu bahan tu juga kita boleh tahu dia brittle ataupun ductile. If kita kenakan satu tekanan, the elongation is less than 5%. Maksudnya panjang dia 10 meter dan bila berlaku pemanjangan 50%, dia patah. So means that dia punya bahan adalah brittle. Kalau bahan tu boleh memanjang more than 5%, up to 20 meter after you kenakan stress, so the material is ductile. So the simple example is brittle, is glass. So ductile is normally for the steel. So that's why most of the bridge is come from the material of steel. And window, biasanya dia tak ada tekanan. Tekanan dia hanyalah wind, angin. So tekanan dia tak terlalu tinggi berbanding bridge. So that's why glass normally kita guna sebagai tingkap ataupun on the wall itself. Dia tak ada yang menahan ke atas bahan tu. Okay, this is type of fracture. So from the figure, we can see here, when we have load, load can be any direction. So you can imagine if dia ada tekanan atas dan bawah, of course after 1 or 2 years, the material akan crack. So the small crack will be happen. And then after that, the crack will be start to open and become larger and larger. So this is the mechanism and how the fracture is happen. And this one is, for example, for the cleavage fracture, void nucleation and closence, and ductile fracture. So fracture ni boleh berlaku ke atas whatever jenis bahan. Apa-apa bahan pun boleh berlaku fracture. This is a general picture of the fracture. Okay, as we can see here, the graph show the load versus the crack opening curve. So here we have a brittle. Okay, from the figure, they have two factors that we consider, the load and also the temperature. So for the brittle, it's clearly stated that even at low load, the material already fractured, and low temperature and low load. The black dot indicates the fracture, and the grey dot is represent the crack initiation. So normally for the brittle, dia tak perlu crack pun, dia just pecah macam tu je. But untuk bahan yang boleh tahan tekanan tinggi dan suhu yang tinggi, normally they will give a sign to us. So the crack will happen, and after that, of course, the fracture will be happen. And how long it can sustain, we can calculate how long the structure tu boleh digunakan ataupun need to be replaced immediately. Okay, the brittle fracture is happen without notice and associated with a release of amount of elastic energy, which for instance may cause a loud noise. The primary factor that promote the brittle fracture is normally relatively large tensile stress, maknanya tekanan yang tinggi, rapid impact, maksudnya you bagi tekanan yang sangat cepat, and also the thick section, maknanya this is depends on the dimension of the material. Okay, the figure shows the concept or integrity assessment. How we assess the materials. When you have a building, you have a materials. This is when the operation start. Of course, the strength is stable as we. This is based on their Young modulus and E is perfect 100%. And after certain time, of course, we need an inspection or maintenance. So during inspection, normally we can detect the small or large crack. So we know that small crack, of course, can be used longer time as compared to the material that have larger crack. So we can predict how long it can be sustained. So when they are surpass the safety limit, normally at this point, this material need to be repaired or replaced for the safety reason. Okay, when you know the strength of each materials, during the selection, of course they have other types of materials. Contohnya you ada saya dah ada satu bahan, cement contohnya, dia very strong, can sustain up to 100 megapascal of force. But you also need to consider other type of factor seperti harga. Of course, we want a low maintenance cost, low cost of the materials, and the material that durable can be used in long lifetime. And in terms of weight, of course, we want a lighter materials and easy to install. So for example, for the low maintenance cost, normally composite types is very popular choice because it can resist the cracking. And some chemical-based product can be easier to be cleaned. If they have a spill, can be easily wiped up with less chance of the stain. And for example, the luxury vinyl flooring and the wall covering. And for the high durability, many paints, coating and sealant in the building help protect it from the element and wear and tears. And of course, we want to have easy to clean paint. For example, for the children room, we need this kind of factor. So other than cost, performance, and aesthetic properties, we also need to consider the environment and health and safety. How the product used in the specific application and the risk and their end of life characteristics. So these all factor we need to consider during the material selection for the building. So as mentioned by Dr. Trianda, you will have in this subject you will dealing with several types of materials such as brick, cement, ceramic, glass, wood, etc. So I just choose one material, so which is brick, because brick is one of the oldest type of the building blocks. They have, we know the brick is cheaper, durable, and required very little maintenance. And there are many ways to shape and to get what is your desired size. One of the common preparation is by extruded, molded, or dry press. So the bridge can achieve its color through the mineral in the fire clay. So when you want to prepare the bridge, the brick, they have a lot of types of clay. So the composition of the clay itself play an important role. You need to mix with the sand, with the water. So this is the final color and the final texture of the brick will be depends on that type of composition. The type of the properties of the brick is the durability, their compressive strength, and absorption. So this one, most of them depends on their chemical composition that I said just now, and also the firing temperature and method of the firing control. Because when during the preparation of the brick, we have a step of the mixture, molding, drying, and also the heat treatment. So during the heat treatment process, we can control their temperature, their duration of the heat treatment. So this one will affect your durability, your texture, and the compressive strength of that material. And for example, for the clay that contain high ion, practically will exhibit the shade of red. So kalau brick to color red, normally they have high content of iron. This is because of they exposed to the oxidizing fire because of the formation of ferrous oxide. So I believe by end of this semester, you will learn about many type of materials. So from there, you know what is the strength. So of course, each type of material, they have their own advantages and disadvantages. And how big your building is also depends on the what type of material that you want to choose. So hopefully by end of semester, you already master of all types of materials, and you can build very strong and long lifetime of the building. And okay, that's all from me.
Okay, thank
Okay.
you very much for your presentation, Dr. Norharyati. Okay, for you guys who have a question, you can ask directly. So, Dr. Norharyati, I just a quick resume what he has already shared to us. It's about the mainly about the tensile strength, right? Tensile
Yes,
strength
yes.
characterization, how it affect. Yeah, it's very important factor for the building materials, and also the composite. As you mentioned about the composite is the feasible way. I mean, the easiest way to increase one of the property of the material.
Yes.
Yeah, it's brick is very good example because in Indonesia we also still applying a lot of like classic bricks because bricks nowadays we have a lot of modern bricks such as based on the geopolymer and so on, but the locals still use brick from clay. I mean, yeah, from a traditional method, still a lot. So maybe as a student you can improve. I mean, give innovation on how to produce better bricks from traditional method. Okay, so maybe that's all. If you guys have a question, please raise your hand, or you can, if you are shy, you can write it on the chat room. Please raise your hand, because this is not an everyday experience. We have a international lecturer. Anyone? Okay, so Dr. Norharyati,
Yes.
I just want to ask you something. So, what kind of parameter that affects the deformation? Sometimes, like as you mentioned, I just remember, but when we are preparing the membrane sample, especially polymeric membrane for the SEM characterization, we need to dip into the liquid nitrogen, which is, I mean, like freezing. So it will affect the deformation process. Is it true, right?
Yes, yes. But
I
that's
mean,
very.
what is?
What is the other factor? So I think based on time and also what is the force that you are exerted to the material. But for the liquid nitrogen, we just dip in very short times. And that's why the rapid impact can make the material brittle. So after we dip coat with the nitrogen, the material become brittle as compared to before we dip into the materials.
Okay, I see. Okay, so I just remember about the Titanic tragedy, right? So actually the Titanic itu kan yang buat itu kan agak sesumbar gitu ya. Ini kapal tak akan pecah. Tapi karena terbuat dari baja, begitu mereka masuk ke apa namanya laut yang es itu kan mempengaruhi the flexibility of the steel, right?
Betul.
Yeah, so it's become like a brittle material. Okay, so that is very interesting. Okay, anyone who's still interested in, I mean, who still have a question in mind, please don't hesitate.
Oh, you can write write in the chatting room if you don't want to.
Yes. Okay.
I hope my presentation is clear.
Yeah, clear. I think. Oh, okay. So we have someone who already raised hand, Marisa Aurelia. Okay, please.
Okay, hello, good morning,
Morning
to everyone. My name is Marisa, and I would like to ask a question. So we've talked about brittle materials, right? So I was wondering if there is any current technology in our modern world that can manipulate brittle materials and strengthen it so that it could elongate its lifetime in usage. That's my question. Is that clear enough for you?
Yes. Okay, thank you, Marisa, for the questions. So of course, when we are dealing with the brittle materials, we can imagine the glass, right? So of course, the glass is very brittle. So now, in a current situation, what we can do is we just put the glass into the other casing, or we can coat the glass with the other materials. So of course, kalau glass contohnya glass pintu kereta, so they have some layer of coating actually. So this is the way we want to enhance their brittleness. Kalau you pecahkan cermin kereta, it's very hard actually. They have some coating plastic layer outside. Good question.
Yeah, thank you. So for you guys who doesn't know about kereta in Malaysia sama in Indonesia different. Kereta kalau di Malaysia itu mobil ya, yang dimaksud Dr. Norharyati itu tadi kaca mobil.
Sorry.
Ya, it's okay. Mobil. Ya betul, memang kaca mobil itu sulit dipecah, dan kalau pecah itu pecahannya kecil-kecil ya. Jadi nggak besar-besar dan sharp ya. Karena kalau pecahannya besar dan tajam, sharp itu kan berbahaya. Maka mereka didesain seperti itu. Very good question, Marisa. Okay, anyone else? Okay, so Dr. Norharyati, how about aging effect? Does aging also affecting the durability in some of the building materials?
Yes. So biasanya dia berkaitan dengan fatigue fracture. So fatigue fracture ni refer to the
Okay.
aging materials. So of course bila dah lama, they need to be maintained. So kalau dinding biasanya kita coat dengan dia punya coating materials untuk enhance dia punya lifetime.
Okay, so jadi ada penuaan ya bahkan di
Ada penuaan,
dinding.
betul?
Jadi tak hanya kulit wajah saja yang perlu
Yes.
anti-aging ya. Building pun.
We need to have a several layer on our skin. Same goes to the wall and building.
Okay. Okay, thank you Dr. Norharyati. Yep. Okay, so anyone else? The same thing also goes on the rubber, right? Like a tire. Tire is if we have a tire for 5 or more years, they become like brittle, like apa namanya? Ya brittle ya. For tire, tire in
Dia
the
akan
car.
crack. Crack. Sebab because of the surrounding temperature. Dia akan mengeras.
Okay, I see. Okay, cool. So, okay, one more thing because I think it's been so long that I have interested in the nuclear engineering. And you also talk about nuclear engineering. One of them is the material. So in nuclear activity, we know we cannot apply any material on it because it's very dangerous. So what would you recommend if one of our students is future will be the nuclear engineering?
Okay, normally for the reactor.
About the material.
Materials. So the most important part or component in the nuclear power plant is the reactor pressure vessel. So where the fuel is inside that vessel. So the vessel is normally made of the zirconia, ceramic type.
Okay. Okay.
That one is because the zirconia is transparent to the neutron. Neutron is the one that release the energy. Of course, after certain time, they need to be inspect onto the crack as well. So the zirconia is the main material for the reactor itself. And it also can stand up to 1000 degree because during the nuclear process, they will release the very high energy and the temperature will be higher, up to 1500 degrees C. So the zirconia can sustain that.
I see.
They also have a corrosion that as compared to the steel,
ceramic base.
The ceramic based material. And they still improvise the zirconium material with the addition of other type of additive. Of course, they still improvise the material.
Okay. So I thought from the G.G. Thomson experiment that used the and the Rutherford experiment that is the alpha radiation. The covering they cover it with the what is timbal lid ya timah.
Timah.
The cover
untuk radiation.
Okay. So now it's moving into the ceramic. Yeah. So now I'm moving into the ceramic material, right? Okay. Cool. Thank you, Dr. Norharyati. Okay. Anyone else? Please ask anything. Maybe about Johor. It's about UTM.
So UTM is very nice place.
Yes, I agree. I believe. You also have your own website, right, Dr. Norharyati?
Website, yeah, under UTM official website. You mean?
I see.
Yeah.
I have read. Yeah, I have read about the what is master and PhD what is vacancy, I think. under
yes,
your
yes, yes. Open every year,
Okay.
every month. So
Oh, really?
whoever want to continue their study in Malaysia in UTM specifically, so please come to MTech.
Okay. Yeah, yeah. The engineering of the UTM is the 100 ya, bilang pick 100 ya, in the world, the best. Yeah, the engineering faculty. It's very cool. Okay, anyone else? Timotheus, you want to ask something? Okay, so Timotheus, okay, please speak yourself.
Thank you, Mr. Trianda. Good morning, Dr. Norharyati. I would like to ask a question. What are the preferred chemical properties of a coating so that it could prevent itching effectively?
Okay, thank you for the questions. So normally for the coatings, of course, we want the material that are less corrosive, that can sustain the humidity and also the temperature, because outside temperature it changes. Bila hujan dia sejuk, bila panas dia suhu tinggi. So biasanya untuk coating material, they use the titanium oxide. Titanium oxide can be is something like catalyst. Dia boleh clean itself. Means that any types of pollutant that stick into the surface, dia boleh degrade. So cleaning process will be easier bila kita ada coating of the catalyst type material. Other than the paint.
Yeah.
Paint also, they have several layers actually for the building.
Yeah, some of the titanium oxide also applied on the glass. I mean, glass on the window,
Yes.
right?
Yes, from the
For
window.
some the high building, for some the high building, they apply the titanium oxide because we don't need to send the people to clean the window.
Yes.
Like
Very
on the
for the
high
safety
building
reason.
side. Yes, yeah. Okay, thank you. Okay, anyone else? Boleh tanya pakai bahasa ya. Karena bahasanya sama, mirip, similar. We
Yeah.
have a similar language.
Ya, mudah boleh difahami.
Ya, yang mudah dipahami. Okay, yang lain. Aurisa, you want to ask something? Boleh tanya sesuatu?
Not yet.
Oh,
Hai.
yeah. Okay. So, how about, I mean, I just want, maybe out of context, I just curious about the UTM, how they conduct during the pandemic. I mean, the education. Is the lab work still available for the student or not?
Okay, lab work only available for the postgrad student because since July, some of the postgrad student already can back to the campus. But now for the undergraduate,
okay.
totally online. For the lab, we practice.
Okay.
So we postpone the registration for the lab subject.
Okay.
Because the lab
no lab.
is no lab. We need to face and hands-on training for the lab. So we just hold that subject first. We continue with the normal lecture using online teaching and learning. So for the postgrad, no problem. They already here since July. So now the case is increased within this month. So we advise them not to go back to their hometown during this time. So you just stay at UTM.
Okay.
So the experiment in MTech still have work as always.
Still running.
Yes, still running.
Okay. Okay, I see.
But we have some
cool.
safety SOP. So we need to wear
Okay.
masks, something like that. Sanitizer is everywhere.
Oh, really?
Yes.
Cool. Okay.
Mm.
So how about the disinfectant chamber? Do UTM also have it?
Oh, sorry,
The chamber,
December
disinfectant chamber. Chamber. I mean, like
chamber.
when you, yeah, chamber, the disinfectant chamber. Do UTM also apply this kind of technology for the preventive reasons? I mean, when you want to enter some building, you need to be scanned first, and
Yes.
uh, there is a spray using ozone or the chlorine to disinfect.
This
So
is
they also apply.
yes, also similar. Every gate we have we need to check our temperature when we enter the building. We need to take temperature. Several
Okay.
layer.
Okay.
Safe.
So similar. Okay. Thank you.
Very
Is there
strict.
anyone else who want to ask maybe about the bridge? Okay, Arif Priangga.
Arif.
Okay. So Arif, please.
Thank you for the chance, Dr. Trianda. I would like to ask about the materials. It is so very interesting. And I have one question about the material resistant to salt water.
Salt water, yes.
Yeah. Should we transform it into ceramic materials or any something else to make the materials too resistant for the salt water? I think that's all.
Okay, thank you Arif for the questions. Of course for the some of the material akan terhakis bila dia contact dengan sub materials. So normally for the steel they have still can sustain the sub material, I think. Trianda, right? Because the desalination system that we have, we are dealing with the salt water. They can operate well using the steel materials. Of course, not all material can be in contact with the salt material. Some of the inorganic material can be leached out when they in contact in the long time under the salt material. If you have a composite materials and you have a composite chamber and the sub material inside, so some of the inorganic or something additive inside the material can be leached out into your water.
Yeah, true. Because when we are dealing with the salt water like seawater, we need to prevent some corrosion, which means oxidation. Like, so we need to something to prevent to prepare a material that can prevent the oxidation. Usually we are using a reduced material like or already oxidized material. So we coat something that already oxidized material, so they cannot be oxidized any further. But also the work with the seawater is very interesting because we cannot predict like the sea in the Java Island and the Sumatra Island might be different because of the percentage of the contamination and so on. That should be taken into account. Thank you, Arif.
The concentration of the salinity also different, right?
Yeah, true. Yeah.
Yeah, thank you, Doctor.
Okay,
Because,
anyone else? Oh yeah, so Amtech is already have a. Yeah, Arif.
Yeah. Because I think salt water or seawater is very useful for building near beach. So I think it is very useful for Indonesian people.
Yes.
Maybe suggestion or something else from Doctor.
Suggestion. As far as I concern, the brick or cement still applicable, still acceptable to build the building close to the shore or salt water.
Yeah.
All right. All right. Thank you.
Thank you.
Brick and some cement. Yeah. Okay, so I want to ask one more thing about the Amtech already have the RO plan on which Penang or Sabah or Sarawak. I think Prof. Fauzi have told us that Amtech already built
Yes,
RO
RO
plan
system.
to convert it.
Mm-mm.
Yeah, RO system to convert the seawater into a drinking water. So what is the pipeline used there?
Sorry, pipeline?
The
Pipeline.
material, I mean. Pipeline. Yeah,
Oh, they use
pipeline.
PVC.
PVC is
because
enough to prevent.
Because they only small
Okay.
capacity. They are the
Mhm.
system is portable.
Oh,
They use PVC.
I see. So
And
we
for the chamber,
okay,
they
so
use polycarbonate container.
okay, I see. Polycarbonate and PVC. Okay, polyvinyl chloride. Yeah, it's very cheap and very easy to operate. PVC. Okay. Anyone else who want to ask Dr. Norharyati related to the strength of material? Maybe about composite, what kind of composite we need to add to enhance the temperature for some instance, or maybe to increase the tensile strength. Like in polymer, we use the mixed matrix membrane. We add some inorganic filler into a polymer matrix, basically to improve the thermal stability, right, Dr. Norharyati?
Yes, because most of the inorganic carbon-based material can sustain high temperature.
Okay. Ya, itu ya. Jadi itu tadi tambahan informasi buat tugas di akhir semester nanti ya. Jadi tadi ada yang harus diperhitungkan adalah strength ya, kekuatan dari material. Itu jadi diujinya tadi kalau secara mekanik itu ada yang ditekan ya, ditabrak dari depan, ada yang digeser seperti ini ya. Ada 3 tadi ya. Dan jenisnya dari kurva tensile strength tadi kita bisa menentukan sifatnya itu ductile atau brittle atau apa berdasarkan kurvanya tadi. Ya memang seperti itu yang sangat berbahaya itu adalah yang brittle untuk kalau digunakan sebagai fondasi karena kita tidak tahu kapan material itu akan putus ya. Kalau brittle kan dia langsung putus begini saja. Kalau ductile dia akan sedikit memberi informasi kayak elongation sedikit. Ya jadi itu karena waktunya sudah berakhir. Thank you very much, Dr. Norharyati. So I just want to present a virtual certificate that I will send you later. This one for our dean, Prof. Hamzah Mansuri. Because I think they already invite you numerous time to come into ITS, right? To come
yes,
to
but
department. So,
tak ada rezeki lagi nak sampai.
ya, sekarang rezeki pun online, via online. So maybe in the near future,
yes.
I hope this pandemic gone soon. Okay, so this is the certificate I will send you through email, the actual files. Thank you very much, Dr. Norharyati, for your time, sparing your precious time coming here and meeting to our student. Basically, my student is your student too because I was your student. So let's also apply. So for anyone else, or if you have any question in mind, you can contact Dr. Norharyati directly through the email. I think she is very happy to receive your email, I think. Or that is just my self-confusion. Okay, so maybe that's all. Before we stop, yeah, please turn on your video because this is the HOP in Indonesia. When conducting a Zoom meeting, we need to have a photo
Yes.
session.
To prove that we are here.
Photo session. Yeah, true. True. So please turn on your video. I will take a photo. Please turn on your video. Okay, we'll wait.
Semua malu ya.
Semua malu. Ini memang kami berencana untuk set supaya mahasiswa di tahun-tahun awal itu ada pengalaman, have experience to meet with the international. So ketika mereka mau master atau menghubungi selanjutnya, nah itu we just want to getting them to used to visit. I'm happy you received my invitation and come here. Okay, so maybe that's all for the video. Please welcome, or maybe my connection is so slow that loads very slow. Okay, maybe I will take some picture, counting from 3, 3, 2, 1, 3. Okay, 2 more. And the last one, you can express anything, yeah? Free expression. Okay, 3, 2, 1, 3. Okay. Okay. And the last one, you can use the filters actually. I will use one of the filters that I love so much. This one. This looks cool. Okay, so maybe one more time you can express anything, yeah. 3, 2, 1, cheese. Okay, thank you very much.
Thank you everyone.
Yeah, thank you very much, Dr. Norharyati, for everything, and thank you for all students who already attend this meeting, and for you guys who cannot attend this meeting, I will share the recording of this meeting into my ITS classroom so you can access it. Okay, maybe that's all for me. Thank you very much once again, Dr. Norharyati. I hope you and the AMTech squad always safe, and I hope also all of the students here are always safe. And please say hello to your parents, students. So keep healthy, stay safety, and stay happy. Peace. See you. Assalamualaikum warahmatullahi
Bye.
wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Oke. Gimana? Sebentar sebelum lift, sebelum lift jangan lift sebentar, jangan lift dulu. Saya ingin ngasih survei ya, nanti mohon diisi, ini cuma isian sebentar ya tentang kegiatan ini. Survei. Gimana? Jadi pengalaman kuliahnya ini? Kaget, berdek, malu? Boleh cerita selagi saya carikan linknya ya. Oke. Sama ya. Nah. Oke, muternya lama ternyata. Saya akan akses dari HP saja. Ternyata lama ya. Saya akan sharekan di grup WhatsApp aja. Karena ini koneksinya nggak stabil. Jadi nanti mohon diisi ya surveinya sedikit. Saya ingin evaluasi juga program seperti ini apakah layak untuk dilanjutkan atau disebarluaskan. Seperti yang kalian tahu, ITS itu punya mata kuliah ya, kimia maksudnya, punya mata kuliah yang basisnya itu sudah bahasa Inggris, yaitu penyimpan energi punya Pak Hamzah. itu bahasa Inggris, full bahasa Inggris mata kuliahnya. Tapi yang ngajar baru Pak Hamzah. Dan mau masuk mata kuliah itu ada syaratnya ya, TOEFL-nya itu minimal 477. Nah, apakah seperti ini akan lanjut karena ini sesuai dengan visi misi ITS yaitu sebagai world class university ya. Jadi mau kembangkan supaya karena kita juga ada IUP kan ya, International Undergraduate Program. Saya ingin yang reguler ini juga merasakan hal yang sama. Jadi in English dan kita datangkan beberapa dosen dari luar. Oke, jadi itu aja ya. Ini nanti akan saya bagikan di grup WhatsApp aja formnya. Oh, ini sudah dapat ternyata. Bentar. Send link. Copy. Bit.ly-nya lama tapi. Oke, itu saya kirim di chat ya. Silahkan akses. Ini juga akan saya kirim di WhatsApp ya. Untuk besok kalian nggak perlu hadir, yang sudah hadir di sini nggak perlu kuliah lagi. Besok kita akan asinkronus ya. Jadi materi yang hari ini kalau itu saya akan upload di My ITS Classroom. Kalau nggak cukup ya nanti saya upload di YouTube ya dengan unlisted ya. Jadi nggak tersedia secara publik. Nah, kalian bisa akses di situ. Oke, jadi begitu saja ya. Terima kasih semuanya. Have a nice day ya. Maaf ganggu waktu kuliahnya ya. Yang lain seharusnya bisa ikut ISOP ya. Oke, untuk yang pertemuan minggu depan kita akan hadir jam 3 ya, sesuai kesepakatan minggu lalu ya. Jam 3. Oke, begitu saja. Terima kasih semuanya. Saya akhiri. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih, Pak.
Thank you so much, Pak Trianda.
Oke, you're welcome. See you.
Ditunggu kuliah internasional selanjutnya, Pak.
Insya Allah ya. Oke.
Ya, Pak.
Ya, saya N ya.
Ya, Pak. Terima kasih banyak, Pak.